Hello, everyone. Welcome. My name is Yolanda Gil. I'm a director of AI and data science initiatives at the Viterbi School of Engineering at USC and director of AI and data science initiatives at the Information Sciences Institute. I'm also director of the data science program. Today, we have a very special training webinar where you will all learn a lot of different aspects of AI and data ethics, not only the issues that arise, but also the technologies that are available and being developed, as well as aspects to do with policy. This webinar has two sessions. One is today focused on data ethics and privacy, and the next one will be Tuesday next week. We hope you can join us as well. I'm going to introduce the three speakers that we have for today on data ethics and privacy. Our first speaker will be Clifford Newman. He's an associate professor of computer science practice in the Department of Computer Science at USC and director of the cybersecurity engineering program. He received his bachelor's degree from the Massachusetts Institute of Technology and his master's and PhD degree from the University of Washington. He is well known for being one of the principal authors of the Kerberos authentication system, which can be used to establish an authenticated communication channel between parties, protecting the integrity of the channel, and optionally protecting the privacy of the communication. He has been working for many years on computer security and is currently teaching several courses at USC in this area, including DSCI 523 on computer systems assurance, DSCI 529 on security and privacy, CSCI 530 on security systems, and DSCI 526 on secure systems administration. Our second speaker today is Tatiana Ryutov. She's a senior lecturer in computer science and received her PhD degree from USC. Her master's degrees from Moscow State University. She has taught courses on information security, computer security policy, trusted system design and development, applied cryptography, operating systems, and computer networks. She is currently teaching DSCI 534 on biomedical data privacy issues and solutions, a new course that she developed. Our third speaker today is Michael Orosz. He's a research director at the USC Information Science Institute and research associate professor of civil and environmental engineering and of spatial sciences. He received his bachelor's degree from the Colorado School of Mines, his master's from the University of Colorado at Boulder, and his PhD degree from UCLA. His research interests focus on behavior-driven decision systems used in operational environments, with a particular interest in data security, cybercrime, homeland security, port security, and intelligent human-computer interfaces. He has 28 plus years of experience successfully managing commercial product development and academic research projects. He currently teaches PPDE 672. It's a course in the School of Public Policy and Planning on exploration of the intelligence community from policy to cyber espionage. The session today will be addressing three major topics with each of their presentations. Cliff Newman will start talking about privacy, security, and policy, giving an overview of those topics. That will be followed by Tatiana Ryutov talking about the engineering aspects of privacy, goals, and implementation. And then finally, Mike Orosz will talk about data privacy and protection policies in the US. We will be starting with Cliff Newman.
Welcome to this seminar on data ethics and privacy, and in particular, the presentation that I'm going to give is going to focus on sort of how different pieces of the problem fit together. Next slide. So computer security is basically a hard problem. There are a number of things that make it a very hard problem. First of all, It's sort of an impossible problem. You can't make a system totally secure. We're going to talk about definitions of security in a few moments, and you'll see that you can make it secure in some contexts for some purposes, but making a system totally secure is not something that can be accomplished. The consequences of failure can be devastating. Look at some of the ransomware attacks we've had recently, shutting down gas supply on the East Coast, affecting hospital systems, or for that matter, disclosure of certain kinds of sensitive information can be devastating. Another thing that makes the problem difficult is that someone wants you to fail. When we think about normal engineering disciplines, we look at sort of statistical distributions of failure probabilities, and you don't assume that you have an intelligent adversary. He's looking at the design of your system and trying to figure out precisely which those things are that they should do to make you fail. In the case of computer security, you have that kind of adversary. Additionally, the bad actors, that is, those that want you to fail, may actually be beyond our reach. When we think of things like physical security, there's a deterrence factor in that the adversary may actually be caught. However, because computers are accessed over the internet, often from foreign countries, they may be beyond our reach, and that eliminates the ability for that deterrence factor. Next slide. I'm going to apologize because I have some, well, actually, I normally have slide building in this, but I guess with the PDF, it'll work fine. So forgive me for the fact that I don't have the dramatic entrance on some of these things. Anyway, we make the problem even harder than I have just described. I told you can't make a system totally secure, so what do? We make the system bigger. If we make the system bigger, there's just more of the system that isn't secure. It makes the problem even harder. Consequences of failure, well, what do we do about those? Well, we actually can't even define very well what constitutes failure. What constitutes failure may depend on who you are, what information is disclosed, and sometimes it becomes sort of a philosophical issue to decide what actually constitutes failure. Finally, we look at the fact that someone wants you to fail and that the bad actors are beyond our reach. Well, what have we done in the last 30 years? We've given all those actors remote access to our systems. It makes the problem even harder. Next slide. Let's try to define the problem a little bit. The problem of computer security. We need to start with an understanding of what it means for a system to be secure. Well, here's sort of a partial definition. A system is secure if it correctly enforces a correctly stated policy for a system. Okay. And we're going to build on this to understand where some of the problems arise in our systems. Now, a system can only be secure with respect to a particular set of policies and under a set of stated assumptions. And there's not any system that is absolutely secure. Next slide. So if we think about security, we should step up a little bit and try to think about what it is that we actually want to achieve. Well, one of the things we want to achieve is confidentiality. We'd like to keep data out of the wrong hands. In a little while, we're going to talk about what we mean by the wrong hands. We may also be interested in integrity, that is, preventing unauthorized modification of data. We're also concerned with availability, that is, we want to keep the system running and reachable, and we'd like to prevent the destruction of system data. Now, this is sort of the classic goals that we want in computer security, and you're going to see this slide again in Dr. Rutov's presentation. She's going to elaborate on it a bit more with the area of privacy, for example. But this gives you some idea of what our goals are. Now, the rest of the problem of security is really policy and mechanism. Now, I'm going to spend a lot of time talking about policy, a little bit of time talking about mechanism. So I'm going to jump to mechanism and talk about that in the next slide. So a mechanism, a security mechanism, is a method or a tool used by the system to enforce a policy. Okay, now if we call our definition of security, a system is secure if it correctly enforces a policy. So the mechanisms are what help us to make that system secure. Mechanisms in computer security can support prevention. In fact, that's what we'd like our mechanisms to do. That is, prevent breaches of security. Maybe prevent someone from accessing data that they shouldn't. Prevent changes from being made. But we also have mechanisms that address detection. Acknowledging that not any system is 100% secure, there are going to be failures, and we'd like to know when those failures occur. There are also mechanisms that react to attempts at breaches or even successful breaches. So those are what we mean when we talk about mechanisms, and we'll list a few of those in a little bit. Dr. Rutov's going to talk about some mechanisms as well. Dr. Arose will talk about some as well. Now, some examples. Access control mechanisms, the things that say yes or no, you can access a file or you can access a system. Cryptography, scrambling data to protect confidentiality, also to protect integrity. There are various availability mechanisms that we can use, and we've got detection mechanisms embedded in things like antivirus systems, security incident event management systems, all examples of mechanisms. Now, there's actually a second role for a security mechanism, and that's to enforce the underlying assumptions in the system. If you recall the extra information I gave you in our definition of security, a system is only secure with respect to a set of assumptions about the environment. It might be secure within certain assumed assumptions and not others. An example of those might be a system might be secure if it's in a locked room and only authorized users are able to physically access that, but you move it out onto the open internet and that security goes away. Well, the mechanism that helps to enforce that particular assumption are things that we talk about as containment. Another common assumption, when we think about policy, I'm going to talk about that in a moment, is that only authorized individuals are able to access a particular data item. How do we determine if they are an authorized individual? In some cases, we need to know who they are. Therefore, identity management, authentication mechanisms are tools that help to assure those underlying assumptions of the system. Next slide. Now, the rest really is policy. Now, when we talk about policy, there are two different things that we typically think about. One, sort of the mechanics of policy. I'm calling it policy in parentheses specification here. And that is what defines what is allowed or not and how the system and security mechanisms should act. It tells us what we mean by confidentiality. It tells us what we mean by integrity, and it tells us what we mean by availability. We had confidentiality, integrity, and availability before. Those were goals, but we didn't say what it meant. Who is authorized? Well, that's what policy tells us. And the policies themselves are then enforced by the mechanisms that we spoke about on the previous slide. Now, another set of policy issues here is really that of authorization. Authorization is really the final goal of security. It tells the system when an operation is allowed or not. So a policy tells us abstractly whether an operation is allowed, but we're going to use authorization mechanisms to evaluate that policy and give back, ideally, sort of a yes or no answer. Can I read this file or not? Now, authorization itself depends upon policy, and it depends upon possibly authentication, and it depends upon other characteristics. Next slide. Now, the other kind of policy that we might think about, and you're going to hear a lot more about this when Dr. Arose speaks about privacy and public access and government access to data, that is what we call public policy. And in the same category, you've got policy based on agreement, even ethics, sort of moral policy in some sense. So public policy includes laws, regulations imposed on data processors pertaining to allowed, quote, processing of data. And I put processing in quotes specifically because that comes into play in some of the privacy regulations that are there. And it's actually an important distinction between some of these regulations and some others. In the case of public policy, there are often legal consequences for not properly implementing security or privacy, and these can be either civil consequences or in some cases criminal consequences. When you look at that agreement, agreed security policy terms include things like contractual requirements such as service level agreements about security, or even things like privacy policies where a company has told you how they are going to handle your data. Now, agreements in terms of policy are enforced in their breach through litigation, often civil, maybe arbitration, maybe other means of redress. Finally, we're concerned with the ethical processing of data, and that is often based on concern for the customer or the data subject, that is, the person about which a particular piece of information pertains. Now, ethical, social, societal norms may differ from location to location or from culture to culture in terms of our expectations of things with respect to privacy. You're going to hear a little bit more about this later, maybe a lot more when Dr. Rutov is speaking, maybe a little bit more, maybe an opposite perspective when Dr. Rose is speaking. It may require consideration of ethical issues in underlying system design as well. Whereas this is more of a security talk, and we typically think of ethical processing in terms of privacy, it's important to understand that ethics in terms of processing of data, in terms of AI, in terms of data mining and everything else, it's not always about privacy. It's understanding the ethics of the use to which a system will be put. And I think this is an important thing that those of you working in data science, working in artificial intelligence are going to need to wrestle with as you think about the kinds of systems that you're asked to implement. Now, with respect to ethical processing, enforcement in their breach is usually based on really public policy, as we spoke about before, or sometimes simply reputation. Next slide. So we've been speaking about policy. Let's now think about where privacy fits in. Sort of the title of the seminar as a whole had privacy in its name. Actually, it didn't have security in its name. But let's think about how privacy relates to security. Well, privacy itself is primarily a policy issue. In other words, it is about what is permitted to be done with data, and that's policy. Now, privacy often concerns what we call personally identifiable information. There's not much in the way of policy with respect to what someone can do with the number 57 or 96 or 23. It is when these numbers or these data values are associated with an individual that we start to be concerned about the impact that it's going to have, whether ethically, whether in terms of privacy or other things. And it is really the linking of data that associates it with the subject and that turns that data into something that needs to be protected according to privacy policies. Now, security and privacy are interrelated. Security is a necessary mechanism to enforce a privacy policy. But accountability and attribution, things that we want in terms of security, might actually create links to subjects that limit the privacy that might be achieved. Now, there are some aspects of privacy also that depend on user education, so that users understand how their data may be used. Ultimately, privacy needs to be balanced with other rights, such as the rights of free expression. And how this balance occurs is very culturally dependent, and you'll see different trade-offs that are made in the US versus the EU versus China and elsewhere. So a lot of the issues of privacy, as well as the issue of ethics, are culturally sensitive, and you need to understand the perspectives that different participants may have. Next slide. Now, let's start to talk a little bit about some privacy regulation, some public policy around privacy. Well, there are certain regulations pertaining to commercial collection and use or processing of data. You're going to hear more about some of these from Dr. Arose in a little bit. But some examples of these: Europe's General Data Protection Regulations, California's Consumer Privacy Act, and then Prop 24 last November, a year ago last November, the California Privacy Rights Act, CPRA. And then just a couple of months ago, you had the Personal Information Protection Law that was regulation set forth in China. Now, almost all of these have as their basic goals accountability, control, and transparency, but there are some fundamental differences. Some of those you may hear about from Dr. Arose and Dr. Rutov. Some of the main ones are whether requirements for processing of data might be opt-in or opt-out. GDPR requires opt-in. California requires opt-out, or the ability to opt-out. Now, it's also important to understand that these regulations that I just spoke about really do not concern government processing of PII. They concern commercial processing of PII. And the regulations with respect to the access that governments have to your information vary significantly from country to country. You're going to hear a lot about this from Dr. Arose. In the US, constitutional rights dictate procedure for access to information, predominantly our Fourth and Fifth Amendments, although interestingly, the First Amendment, that is free speech and compelled speech, come into play in some of the arguments that are playing out in the courts in this area. In some cases, at least within the US, government use of data is actually more limited than public commercial use. Sort of funny that, in the sense that we're saying, well, yeah, this information may be publicly available for commercial use, but we're going to limit the government's ability to access this information in certain ways. In other countries, though, government access is presumed to be pretty much unlimited. Now, it's important to understand that we're talking about the internet. The internet crosses jurisdictions. In fact, a particular operation, a particular access to a website, for example, involves parts of things that occur in different countries. And some of the rules are, in fact, extraterritorial. It creates an issue when you have conflicts between different jurisdictions. Next slide. Now, the next thing we're going to talk about in terms of really privacy is sort of ethical data processing. We think about ethics. I'm trying to put in your mind sort of the idea of some intrinsic things that might be less contextual from a cultural perspective. And I think one of the things that is important sort of across the board is that transparency is a key goal of most privacy regulations in the form of maybe required disclosure. And in some cases, the need for consent of the purpose for which information is collected and processed. Certainly in the case of commercial processing, I'd say that this should probably be the case even in the case of government processing as well, although that's not always the case. But what happens if the roles or the purpose for access to data changes? Well, you'll see some of the roles are written in ways, things like GDPR, such that consent is obtained for use of data for a very specific purpose. If the purpose changes, consent needs to be obtained all over again. I think a worthwhile principle of ethical data processing then might be to take the steps necessary to ensure that data can only be used for the purposes for which disclosure was made. And this is going to be incumbent on you as the developer of a system. And the basic tools that you can use to assure this are: one, data minimization. Basically, the idea is don't collect data if you don't need it. Because if you don't collect data, it can't be misused. If you don't collect data, it can't be stolen by an adversary. Another component is data protection. If you collect the data, you have an obligation to protect it so the adversaries, the criminals, are not able to break into your system, obtain all this data, things like we saw with the Equifax data breach, or the data breach in the US Office of Personnel Management, or other things. And some other things, and you're going to hear a lot more about this from Dr. Rutov, are applications of technologies that can limit linkability, things like anonymity, differential privacy, or if we want to think about forms of anonymity in terms of accessing information on the internet, things like anonymizers, things like onion routing, the Tor network, for example. You should also think through the potential for misuse of your system or technology, whether it's by criminals, by corporations, by governments, or even by your end users. You're designing a system for an end user, make some decisions about what they are trying to use your system for and whether it is consistent with your ethics. Some other things, are there biases that are present in the technology or the data sets and processes? So one of the things that, maybe it is a privacy issue, but maybe it's a systemic issue as well. There are certain biases that end up being propagated or translated or reintroduced to a system, and you need to think about these issues. You think about your processing of data. What can you do to prevent the possibilities of misuse? Next slide. So that's sort of an overview of how a lot of things fit together. Now, if you're trying to protect systems, there are a lot of mechanisms that you're going to hear about from Dr. Rutov, from Dr. Arose, but there are some steps you should take first before you start trying to secure your system, before you start trying to make your system more private. And that is, you need to think about and determine what you must protect. And that begins with an assessment. Thinking about what's important. Take an inventory of the data that you plan to process. What's important to you? What do you have, or what are you asking for that is important to others? What are the consequences of loss or disclosure? And think like an adversary. What can a third party do with this data that might not have been intended? Now, you also want to take an inventory of your systems. That is the hardware, the software, the apps you have installed on your system, because this is how the adversaries get at your data. Think about where the data is stored. What systems do you have that process the data? What software do you run on those systems? Because each new piece of software is a potential set of vulnerabilities that an adversary can exploit. What are the vulnerabilities that exist on your system? Now, these problems become even more difficult when we think about cloud processing, because now it's not just the data on your system, it is the data that you have entrusted to others. Next slide.
Cliff, it is my job to keep track of time, so I want to give you a 5-minute warning.
Okay, I think that should be fine here.
Tell the audience to post questions. We'll take all the questions for all the speakers at the very end, so you can post them in the Q&A window.
Okay, so given what I've just told you in terms of understanding the information in your system, understanding the systems themselves, and given that I told you that no system is 100% secure, what can we do to protect the security of our systems? Well, we can not use our systems. That's really not an option. So the real thing that we want to apply in terms of security is to manage the risk that we incur. And risk can be described as consequence times likelihood. Unfortunately, our calculation of risk can only be as accurate as the values we enter for consequence and likelihood. And for security breaches, these are often no better than guesses. So why then is risk management useful? Because we know the steps that reduce likelihood and that reduce consequence. Next slide. Next slide. Hello? Okay. So some of the things we can do to reduce consequences are based on that inventory that you just took. Consider the consequences from the data in your inventory. What happens if you lose access? What happens if someone else gains access? Well, things to reduce the consequence. First, if we're concerned with availability of data, effective backups. If we're concerned about the disclosure of data, don't keep the most sensitive data on connected systems at all. Pull them off onto a separate disk that is disconnected from your computer, or don't store it out in the cloud. And finally, reduce what can be accessed from your systems, because oftentimes an adversary that exploits a vulnerability in your systems does so in order to obtain information that is accessible from that system. A good takeaway: treat personally identifiable information like toxic waste. If you collect it, you have to protect it. You're better off not collecting it to begin with. Next slide. So the next thing we look at is reducing the likelihood. Well, the likelihood is threat times vulnerability. Let's think about reducing the threat and vulnerability. Well, what we want to do is reduce attack surface by blocking access into the applications and systems that you might have. This can be accomplished by minimizing the programs and the function. We can also reduce bugs and apply patches to systems. Next slide. So there are a number of tools that are useful in trying to rein in the risk that we have. Among these, well, I already told you, take an inventory of their configuration management. You're going to hear from Dr. Rutov about a number of containment mechanisms, including things like firewalls, including things like encryption. Access and identity management, I already spoke about. This helps to provide assurance about some of the underlying assumptions about who's using our systems. We've spoken about detection and response. But above all, the main thing that I like to stress, the simplest thing, is minimization. Get rid of data if you don't need it. Get rid of apps if you're not using them, because that's extra vulnerability. And make data less accessible, moving it to more constrained and protected parts of the system. Next slide. So some guidelines to remember, sort of wrapping this up. A system is secure if it correctly enforces a correctly stated policy. Policies themselves describe the rules for the goals that we had of confidentiality, integrity, and availability. You can't make a system totally secure. Privacy is in fact a statement of policy, and it depends on the security of your system as well as the proper statement of the policy that you choose to enforce. Data should only be processed for the purpose for which it was collected, and security and privacy requiring managing risk. Again, as I had on the last slide, the most effective and simplest steps in protecting your systems involve minimizing our systems. Think less is more. Fewer programs, less access, and less data. With that, thank you, and we'll take your questions at the end of all the presentations.
Thank you, Cliff. That was very comprehensive, but also it made very many things more clear, at least to me. So thank you so much. We'll move on to the second segment of the presentations from Tatiana Ryutov. Go ahead.
Okay, can I share my screen?
Yes.
Okay. All right. Thank you for this opportunity. Today, I want to talk about privacy engineering, an emerging field of engineering which provides techniques and tools to ensure our systems support acceptable levels of privacy. So we'll discuss main challenges of data and privacy protection goals, and we'll briefly consider non-exhaustive list of current privacy technologies and techniques supporting those goals. We will focus a little bit on genomic privacy and consider emerging novel solutions that appeared, in particular, the dynamic encryption and watermarking of genomic data. So before we start, let's just clarify some terminology. So data security and data privacy are similar concepts with overlaps, but they are not the same thing. So the main difference is that privacy usually takes the perspective of an individual who tries to fight back against the control of others. It refers to the right to be left alone. It's a part of human dignity. Similarly, privacy and confidentiality are not the same thing. Privacy relates to individuals and what personal data is collected and shared, while confidentiality is about protecting the access to the data. Data protection refers also to the organizational perspective. So you see, therefore, the goals of data protection and privacy protection have some differences. So, well, we see here CIA Triad that Dr. Newman described, and in the interest of time, I just want to jump in. I don't have time to talk about this. So let's just jump in and talk about how these three goals, confidentiality, availability, and integrity, are typically implemented. So some strategies include data minimization strategies that Dr. Newman talked about. There are a couple of aspects here. Purpose limitation, personal data should be collected for specified, explicit, legitimate purposes, and also data minimization itself. So that states that personal data should be adequate, relevant to the respective purpose. And common design pattern is strategy: select before you collect, right? You can either not collect any information or reduce the set of attributes that you're collecting. In addition, of course, personal data must be erased as soon as it's not needed anymore. Also, data minimization is a core concept of privacy enhancing technology. Unfortunately, it has not been well enforced yet. So another strategy is to separate or segregate personal data that should be processed in distributed fashion in separate compartments where possible. So for separating the processing or storage of several resources of personal data that belong to the same person, if you separate that, complete profiles of one person cannot be constructed easily. And moreover, this separation is a good method to achieve purpose limitation. So another strategy is to prevent people from getting access to data by enforcing rules, like login procedures and checking access control policies, such as, for example, what role do you have? Are you a doctor? Are you a nurse? And so on. And then authorizing data access based on the role. And for many, many years, that has been the prevalent way of protecting data. Another very popular strategy is hide personal data and their relationship. And of course, cryptography gives us a set of very useful technologies to achieve that. Data can be encrypted in transit, at rest, or in use. So when we need to protect data in transit, basically when it passes from network to network, or let's say moved from local storage system to cloud storage device. So, you know, that we have to protect it. And most email providers, for example, use TLS or transport layer security encryption automatically to achieve that. Now, data at rest is when it doesn't travel actively from device to device. It's basically being stored somewhere on the hard disk, laptop, flash drives, and so on. So we want to secure this inactive information stored on any computer network. And, you know, it's also used very widely. So most of database management systems available today include native encryption techniques. And finally, we have to protect data in use. So whenever information is not only stored, but actually actively processed by applications. So you see what happens, data is being created, viewed, modified, removed, and so on. There are techniques to achieve that. So homomorphic encryption is a holy grail, which supports processing of data without learning the data content. So imagine it's possible to calculate larger than relation for two encrypted values without revealing the actual values. So it's pretty amazing. The realization of integrity is mostly based on cryptographic techniques that allow detection of modification of data. So examples are digital signatures based on RSA or elliptic curves, message authentication codes, and so on. Other means of supporting the integrity protection goals are based on redundancy in comparison. So data verification, and again, access control mechanisms. So unlike confidentiality and integrity, availability cannot be realized just, by applying cryptographic tools. Cryptography actually can be an impediment to availability. So think about it. If you lose your cryptographic keys, you won't be able to access your data. So availability can be realized by adding redundancy to the system, such as storing multiple copies of the same data in different storage locations. So, if one copy is destroyed or changed or altered, like for example, encrypted by a ransomware attack, the other copies are there and we can restore the original data. So also techniques like load balancing and avoiding a single point of failure is another example of availability techniques. Okay, so these were the 3 CIA data protection goals that we discussed, but now let's focus on privacy. We need to complement these 3 goals with privacy goals. So here are the 3 goals that I'm going to talk about, which stem from the German data protection community. So unlinkability expresses the inability to link related information. For example, like packets, network packets sent, events, people, actions, and so on. So unlinkability refers to the property of anonymity, hiding the identity of the parties involved in communication with one another, or hiding from third parties. So that was unlinkability. Next, transparency means that anything a data processing system does, such as that data collection, processing, storage, or even future planned processing, should be understood and could be reproduced by those who are using the system or running the system. So transparency, openness basically means that people should get sufficient information about the collection of their personal data. And finally, intervenability means that the data subjects, so these are people whose data is being collected or processed, can intervene and change ongoing or even planned privacy-related data processing. So the objective here is to apply corrective measures when necessary. And so this is an ability to control how data is processed and by whom. So for example, individuals can request erasure of their data or decide to withdraw a consent. Okay, so these are the 3 goals. And now let's briefly talk about techniques and technologies that we have. So let's first briefly examine implementation strategy to realize unlinkability. So, well, the, aggregation, I'm sorry, this is a different slide. Okay, unlinkability, so this is right side. Apologies for that. So aggregation states that personal data should be processed at the least possible detail, which is still useful. So we can aggregate information of groups, of attributes, of individuals to restrict the amount of detail. Information stored is valid for many individuals, since little information can be attributed to a single person, thus, of course, protecting privacy. Examples could be, examples of aggregations could be something like aggregation over time, which is used in smart metering, dynamic location granularity used in location-based services. Data anonymization, very widely used, but there are studies that have found that anonymized data still could be linked to real identities of users. So, and therefore, more advanced approaches such as k-anonymity and especially differential privacy provide better linkability. And to protect users from being observed when they do, like they're browsing, the accessing a service, for example, techniques such as crowds, mixed nets, or routing such as Tor can be used. So now let's talk about this important notion of transparency. Data subjects should be informed whenever personal data is processed, and this can be done based on specific requests. For example, what do we store about person X, or proactively by sending notification messages. For example, a photo was uploaded to our server by person Y. And of course, data breach notifications also fall into this category. And next, well, finally, let's talk about this intervenability, which is very, very important, but really hard to achieve goal. It's about control and direct action. So for instance, this would be means to ban data transmission to third parties, to correct data errors, such as like fixing typos and phone numbers, to delete certain data or part of data. So such mechanisms include processes for influencing or stopping the data processing, either fully or partially. Something like manually overwriting an automated decision, like break glass policy, single point of contact for intervention requests, changing a setting. So in the context of social networks, for example, users can update their privacy settings to set some more strict level of control over their data. Well, unfortunately, currently, this intervenability has way less practical technology. So typically, implementing intervenability is very challenging and it's very costly. So that led companies neglecting the intervenability options for their customers. And what typically can be found is just some configuration menu for users, personal data, and a clerk-operated help desk. That's pretty much it. So interference with ongoing process, however, is very rarely implemented. So next, what I want to do is want to concentrate on this hardest to achieve privacy goal and show how we can approach solving this problem. And the focus for what follows is on genomic privacy. That is the privacy of genomic sequencing data. So we'll discuss a way to achieve intervenability in this particular context. And interestingly enough, intervenability is not completely independent. It requires sufficient transparency because lack of transparency actually, and the lack of transparency may be actually a reason to intervene. So there is clearly dependence here. So I will talk about the work that I've done in collaboration with researchers from CHLA Center of Personalized Medicine, Alex Rutov and Guy Chavou. We developed two algorithms to enable this fine-grained flexible protection of genomic data that I want to talk about. But before, I want to give some motivation. So misuse of genomic information, genomic sequencing data may lead to critical consequences, including discrimination against the individual. And de-identification is very often and commonly used to conceal the identity of an individual in biomedical research. But there are two main issues with this approach. First, it's been shown that re-identification can be achieved by complementing this anonymized data with additional data such as state, age, last name. But more importantly, it's nearly impossible to hide one's identity by identifying genomic sequencing data. Genomic data is unique to the individual. And because of that, many propose an open access model. There are projects like All of Us and Personal Genome Project, PGP. Participants are encouraged to publicly share their personal data, including the genomic data, for greater good. And this is really controversial because, first of all, the participants likely not be fully aware of potential consequences, since more knowledge about our genomes may be only available in the future. We don't know everything yet. Next, the genetic information, in fact, is not private. It is shared among family members and relatives who may be impacted by the decision and not being able to ask for consent. And the emphasis, this emphasis on sharing is caring might guilt trip, some people to share their genomic data unaware of those risks. So you see what's happening. The traditional view of privacy as a secrecy or concealment, as a right to be alone, becoming obsolete. Focus shifts from just concealing the individual identity. And now we have this genomic privacy, which is understood as providing the individuals the control over the sharing and use of their data. And traditionally, genomic privacy has been achieved by informed consent. So the problem is that genomic studies often involve analyses that are not anticipated at the time of original consent. So for that reason, often a broad consent is used, which defines pretty much no restrictions, so very few restrictions on the use of data. And the problem is that participants have or have very little control over their data once the original consent is signed. It's signed, it's gone, and you cannot take it back. So informed consent is becoming obsolete, and the privacy law involved in US and abroad, we know about the GDPR, but GDPR dictates essentially two rights: the right to be forgotten and the right to revoke consent. Unfortunately, those rights are typically disregarded. If you look at the way how genomic studies are currently conducted, how the data collected, managed, used, this is not happening. So to address this, what we need is ownership-based model. And the owners of genomic data should be able to continuously control the access to their data and to share intellectual and even monetary value derived from the usage of their data, because you can sell this information and it actually costs quite a lot. So as we discussed, there are legal and ethical challenges that cannot be met by conventional consent models that we have. We also noted the lack of informatics methodologies, techniques to facilitate this genomic data sharing and to address the challenges associated with that. So we need this ownership-based data governance, meaning that data subject ultimately controls the access and shares monetary, intellectual, and personal value of the shared data. All right, so that was the motivation. And now I would like to briefly talk about the proposed solution. This is new things that we've done, very exciting, it was a very interesting project. So we look at, again, some work done with the Center of Personalized Medicine from CHLA, and we developed two new algorithms, one for dynamic encryption and another one ownership preserving watermarking. So what's interesting about this is that these algorithms can work with standard data formats which are used in bioinformatics. One is BAM, binary alignment map, and the second one VCF, which stands for variant call format. So they're used everywhere by all the tools. And this support for this standard format without any modifications allows to apply our methods transparently. You can just integrate them easily with current existing genomic pipelines. So one can use this mechanism either individually or together to be able to specify and revoke authorization. So you signed your consent and then something changed and you can take it back. So we actually implemented, so it's not just something that we've come up with algorithms, we actually implemented it as a part of Luba Priad privacy enabling tool, which is implemented in C++. It's a kind of easy to use, but it's command line application. Sorry, no graphical user interface yet, but it's not that difficult to use. Well, so just a few details of our approach. So we use, in addition to our new things, we use what already exists. So we support these flexible fine-grained policies based on ciphertext attribute-based encryption, CP, ABE for short. So what is ABE is a type of public key encryption which supports very fine-grained access control policies which are cryptographically enforced. You see, you can specify your policy as a logical set of attributes. You can specify time, purpose, and things like that, organize those conditions in this logical formula, and embed this into the ciphertext. You encrypt it, and all these things are inside the ciphertext. It's impossible to remove them. And you can only decrypt the ciphertext, the data that you protect, if and only if you can present the corresponding attributes, and only then the data will be decrypted. So it's amazing what you can do with cryptographic techniques. However, there's a problem. Enforcing policy requires auditing, because once your data is decrypted, all protection is gone. Suppose you want to not be able to access data after a certain time period in next year. Well, data is decrypted, can be copied. How can you protect that? So for that, we need additional mechanism. And this is watermarking of genomic data, which can support this detection of unauthorized data sharing and use. For example, some encrypted BAM was shared with another institution without data owner consent, or maybe it was accessed, after the authorization expired. So you see, when you decrypt your data, watermark is still there. It doesn't disappear. So it's a great technique which allows us to deter and control the use of data after data is decrypted. So here I'm showing you just overview of how one of our methods could be used. It's dynamic encryption usage. So you see on the right here, there are a couple of data consumers. There is a 23andMe and a Tech School of Medicine. So what happens is encrypted data can be downloaded, and then we have on the left data owner, a person whose data were collected. And data owner can set their policies by embedding the policies. I'm showing here this as a logical tree, and can grant a different access to different data consumers. For example, you can grant more access for free for clinical purposes, or you may require payment for commercial purposes. And of course, you can also decide which part of your genome, what gene you are willing to reveal. So it gives us very, very flexible techniques to do this. Okay, so, well, if you get this piece of key stream, which is protected by this ABCP policies, you'll be able to decrypt part of the genome. Okay, so what do you do with this part next? Well, you use a mechanism such as IGV, which stands for Integrative Genomic Viewer. That's widely used, and it's pretty easy. So this is what you see when data is decrypted. So this is how the data are being analyzed. So just few details about our encryption mechanism, which is shown on the left. And on the right, what you can see is the top picture shows the genomic data. We are focusing on this APOE gene, which is responsible for Alzheimer's disease. So you could see here everything. And if you decide to encrypt one gene and leave others open, this is you would see. So the picture on the right below shows this kind of this gene, this sensitive gene is missing. Okay, so that was dynamic encryption of genomic data. And the final thing that I wanted to talk about briefly, I hope I have time. Yolanda, do you have any time left?
You have five minutes. I was
okay.
just about to give you the 5 minutes.
Okay, 5 minutes. I'll try to. So what you said is that well, we have this flexible way to encrypt policy. Great. But once you decrypt, everything is gone. So what can we do? So here we are suggesting this watermarking technique, which will persist even when data is decrypted. And it kind of acts as a deterrence for, don't share your data and violate the policy, because we'll find you and, keep you accountable. So what happens? What the idea here is to select different but overlapping watermarks and share the same set with multiple entities. You can even sell your genomic data multiple times, which is cool. You can benefit multiple times, get paid multiple times, but you see your genomic data doesn't change over your time pretty much. So kind of you're selling the same thing multiple times, and this watermark gives us this ability to keep track of that, because your original policies are still embedded inside of this watermark, and it's hidden in this inherent noise. So you see many techniques which apply watermarking, well, in digital content, they, like movies, they destroy the utility of data. But genomic data is very important, because you make all kinds of medical decisions on that. It has to be, the utility has to be preserved. So that's a problem with this kind of data. It's not a movie where you can change some pixels and that's all. You really have to preserve the utility. So we hide this in the noise, and the idea is pretty neat. So I'm showing here two screens, one and another. I don't know if you could see, there is this tiny circle on the left. So this is how Watermark looks like. So that's a piece where one of the bases was changed. Okay, I don't have time to talk a lot about that, but so we embed in this watermark based on a key, a secret key, which is hidden, and you can reproduce this. So if you don't know the key, you won't be able to find the watermark. And on the right, I'm showing you the Monte Carlo simulation that we've done, which shows that if you know the key, you will be able to find all watermarks. If you just try random keys, you will find just tiny bit, and it's, you know, it's clear that you were guessing. Okay, so I hope, yeah, I guess it's 5 minutes. I have 1 more minute. So basically what we did is we did a brief overview of the core challenges of each: data privacy and data protection goals. We glimpsed at the state of the art today very briefly. It's not an exhaustive list of things that people are doing now to support these goals. And we also discussed this issue of genomic privacy and propose solutions based on dynamic encryption or watermarking of genomic data. Well, thank you very much for your attention. That concludes my talk.
Thank you very much. That was great, and gave us a really good overview of the technologies and the possible aspects of a secure system and a system that respects data privacy. Please post your questions in the QA window, and we'll proceed in the meantime to the presentation from Mike Orosz. Go ahead.
Okay. Hope everybody can hear me. So good afternoon, actually good evening. I'm going to talk a little bit about data privacy in terms of policy here in the US. You know, basically we're going to scratch the surface actually as to what policies are out there and how they're implemented, and some of the issues involved, because it's basically a whole semester just to cover policy issues in this country, and they change all the time. This is part of a course I teach, and already it's been mentioned, PPDE 672 out of the policy school. So if you're interested in learning more about policy or the intelligence community, please let me know. And so basically I want to talk about, again, you know, this idea that genie out of the bottle problem, and in policies that govern the private sector. You know, what policies exist that deal with, you know, businesses and private communications, et cetera. And then talk about some policies that govern how the government interacts with privacy concerns, particularly an emphasis on the law enforcement and intelligence communities, since until COVID-19 came along, were the dominant discussion about what the government's doing in terms of accessing your data. So the genie out of the bottle, again, this is something that Professor Newman and Professor Rutoff talked about, but you know, you can have theft of physical property, and you know, with time, it can usually be returned or replaced. You know, artwork, if it's stolen, sometimes you can't get it back, but there's usually an insurance policy, so you get something back. Theft of electronic information, particularly digital, what we're talking about here, digital data, is more difficult to correct, but in many situations, there are legal frameworks and that can be leveraged to help mitigate. So if IP is stolen, for example, a copyright is infringed on, there are civic and in some cases criminal processes that can be used to at least compensate you for the loss. But where the exception is, of course, is in personal identifiable information, PII. You know, once it's out there, it's almost impossible to get it back. And you know, and there are policies around the world that say, you know, you have the right to be forgotten, but you know, it's not forgotten. It's out there. There's ways to find it. And so once PII is out, the genie's out, and you can't get it back in the bottle. So types of data, just to reiterate that, you know, there's all kinds of data out there that we're talking about. Intellectual property, of course, we skimmed on already, but sensitive data, usually state secrets, but can include business information. I'm not talking about PII data here, but, you know, data that, you know, you want some protection on, you don't want the public to really see it. and that includes even the top secret stuff, and of course PII, and that's the subject of this discussion. So before we get into the policy, just some, again, reiterating some of what Professor Newman and Professor Rutov talked about in terms of ethical responsibilities. Due to the genie out of the bottle problem, we have responsibilities, all of us, and it's easy to overlook this responsibility. Sharing data with others, once you lose chain of custody, it's vulnerable. Once you send a file someplace, if you don't know where it's going or they haven't taken their appropriate precautions to protect that information, it's gone. So we have a responsibility to check out, to do our due diligence to determine where that data is going, and sometimes there's accidental exposures through data breaches like third-party clouds, which is one of the reasons why some businesses still will not rely on clouds, because it's out of their hands. Again, they're doing their due diligence, and from their business perspective, their business model, it's cheaper to do it in-house than to farm out some of these data storage or processing challenges. And a big problem is not slowing down. This is really human behavior. The classic example is sending an email message without thinking about the consequences. It happens to all of us. But really, from an ethical point of view, we really need to slow down and think about what we're doing before we hit the send button or store a file someplace. So again, just some considerations from the ethical side of the house. So the private sector, all right. So protection in the US, well, as you probably already know, there's no federal level General Data Privacy Act or policy or regulation or even guidelines. Unlike the General Data Protection Regulation Act in the EU and in other countries, there just isn't. It's come up many times in Congress to pass laws on this, and we'll talk about in a minute why they don't get passed, but there isn't one. However, there are nationwide regulations that cover certain sectors, and probably the most famous one is the HIPAA Act, in particular Title II of that act, which talks about protecting personal information. And in the sister act, the HITECH Act, which came along with the recognition that HIPAA was really just talking about medical data in general, health information that you have to protect. What the HITECH Act does is it looks at it from the electronic point of view. It's promoting that the health industry needs to go to electronic records. And of course, those electronic records need to be protected. So the whole cyber realm is part of what HITECH is. So it augments HIPAA. Again, the health community in this country, there is a national-wide policy regulations that govern PII. There's also acts that protect the privacy of underage children. The COPA Act, children 13 years and younger, and that crosses the whole country. But really, that's, there's some others, but those are some of the main ones. But there's no general protection act. Okay, some reasons for the lack. Well, cost of business to implement is high. No surprise there, especially existing processes and business models to go back and rework them to support a policy, a general data privacy protection policy would be enormously expensive. And so those costs cause business to influence Congress's decision-making as to whether they should pass such a law or not. Not a surprise there in this country. Access to PII is part of the business model. So many companies rely on that PII for their own internal marketing processes, but also to share with corporate entities that they may do business deals with, et cetera. So it's part of their business model to have access and to share PII data. So again, another reason why they may influence Congress not to pass a general wide policy. Low priority. This is particularly true in the last year or so because of the challenges we've seen with COVID-19 and the election of 2020. it's sort of fallen down. It's not as high as a priority, but this changes all the time. It was pretty hot for a couple of years prior to the last 2 years. And it'll come back as we have more data breaches, more ransomware challenges. And so you'll see more bills being presented in Congress to try to address this. And then there's the recognition that the US can't govern the rest of the world. So, you could protect and set up policies with businesses and even individuals in this country, but what about outside the country? And as Professor Newman mentioned earlier, the internet, there are no boundaries. And so this also weighs in on the decision making in Washington, D.C. as to, what does it mean to implement data policy or data privacy across the country? So some challenges there. That said, there are state level acts and regulations. So, local, right? And so there's, of course, the California Consumer Privacy Act, which was passed in 2018 and implemented, I think, in 2020. And it basically gives you the right to, know what's being collected from the business community, right to destroy it, and a right to opt out of data collection processes within a business. Unlike Europe, where you have to opt in the US, you have to opt out. And then the California Privacy Rights Act, again, what Professor Newman talked about, implemented or voted in, this is Proposition 24, voted in November 2020. It will take effect in January 2023. And what it does is actually adds a little more power to the CCPA. It actually establishes an authority to provide oversight and to prosecute where there are violations in the CCPA. It also did set aside a definition of small businesses that just cannot afford to implement the rules of the CCPA. They're exempt from it, so define that in this new in Proposition 24. But Proposition 24 also implemented this idea of a sensitive private information, which is something that you see in Europe. There's a difference. There's private, personal, identifiable information, and there's sensitive, personal, identifiable information. So there's special handling techniques that have been defined in the California Privacy Rights Act. So that's California. Colorado has a similar act. Maine, similar. Massachusetts, and I can go on and on. They're all regional, mostly state-based, some even city-based. But the idea is that again, there's no general federal level. Most of it's very localized, and the challenge here is that if you're a business and you're doing business across the country, you could have 50, 60 different policies you have to implement some kind of a procedure, and if they differ, and they do, that's a lot of overhead, and so that's a real challenge in the business world. So some of you may be researchers, so you might think, well, that's businesses and etc. But even in the research community, you have policies that govern what you can and cannot do with the data you collect and analyze, and where you can store it and who you can share it with, etc. For example, if you're funded by DARPA or IARPA or NSF or NIH or just about anybody else, they require a data handling protection plan to be submitted part of the proposal and implemented during execution. And they're very serious about this. This is a critical part of the proposal evaluation process. In addition, all universities that I know of, and including and even research undertaken in the private sector, say like a defense agency or a defense company, they have internal review boards that look and evaluate your data policy plan, your data handling plan, how you remove names, how you share data. And an example of some of the, I put a URL here, so if you're interested in seeing the one at USC, I know these notes are being distributed, so you can click on that and just see an example of a data use agreement form. I won't bore you with the details, but in general, you'll see something like this in any type of data handling privacy protocol that's required by the government. If you're doing research, all names and other identifying information from people's data has to be removed prior to distribution or publishing. You can't use data that violates any other laws that are federal, state, or local. Obvious stuff here. A major one, the third bullet, it's a need to know. You don't share information with anybody unless they have a real need to know. So it almost sounds like we're in the the intelligence community, but this holds for any type of research that you do in a university. Store information on protected computers. Again, obvious stuff, but if you don't put it out there in written documents and enforce it, it can be quickly forgotten in the heat of battle. And if there is a breach, we are obligated to notify people that there was a breach and that their PII is at risk. So and I'm going to switch gears and go into the government side, and in particular focus on the intelligence community and federal law enforcement as to what they can and cannot do. And what's really ironic here is that, and Professor Newman mentioned this earlier, for a while people were complaining and very concerned about government getting access to their data. The reality is the government's pretty handcuffed. Doesn't mean they don't get into some things that they shouldn't be getting into, but they really are handcuffed. While the commercial sector, Facebook and others, you've seen the headlines, they get access to a lot of data. So it is ironic that the government is focused on, but reality is other companies have a lot more freedom with data. So what you'll find in the US is that there's a pendulum basically that swings between security and privacy. And it's really driven by, a lot of times national security events. So that, privacy might be the main focus, both federally and at state and local levels. And then some event will occur, there'll be an overreaction, and there'll be laws enacted like the Patriot Act after 9/11 that swings that pendulum over to the security side at the expense of the privacy side. And you see this throughout the history of this country. And this back and forth, there's a balance. And I would argue it's what makes really the US unique amongst the world. We don't always get it right, get it wrong maybe too many times, but there is this constant struggle or tension to try to get the right balance, as we've noted earlier in this webinar. One of the big driving issues from the intelligence and the law enforcement side is what is a US citizen versus a US person? As you will see, almost all of our policies are driven by or impact US persons, not US citizens. And so a US person includes US citizens either by birth or naturalized, green card holders, H-1B and other special permit holders. They're all considered US persons. And so they fall under all these policy issues and policies that have been declared and implemented via laws and acts. A visitor, whether documented or undocumented, is not considered a US person. However, we as a country, most of the time, try to respect their privacy simply because this is a global world, right? It's round. We travel to other countries. We would hope that they would do the same to us as we do to them. And not codified in law in most cases. There's some laws, but for the most part, it's something that we really should try to do a better job of. So speech versus privacy. So, and this was talked a little bit about, Professor Newman covered it, but unlike the freedom of speech, which is the First Amendment, the right to privacy is not specifically guaranteed in the Constitution. For example, you can take someone's right of speech away, but eventually you can get it back, okay, through legal channels, lawsuits, etc. You can get it back. I'm not saying we should be doing that on a daily basis, but at least you can get it back. But the right of privacy is inferred by the Fourth Amendment, which is the freedom from unreasonable search and seizure, but it doesn't guarantee, at least from the US government's eyes, your privacy. And some of that's driven by what we call the Third Party Act, which is that if you have given information to a third party, like a telecom company, you make phone calls, right? And your metadata is stored, who you called and how long you called and what phone numbers were used. That's metadata, that's giving it away to the third company or third party, and therefore the US government has used this rule to gain access to US persons' information. So more on that later. Further, as you can imagine, we have this reasonableness, which is, the Supreme Court has said that, reasonableness is also can justify a warrantless search and collection and analysis of intelligence on a U.S. person. This is protected. It's been fought and successfully defended in the courts. And of course, the whole question is, what is reasonableness? And that again can come down to lawsuits, either criminal or civil. But we do have this in our laws. So this thing is blocking my view. I can't read the title, but I'll move forward. So yeah, okay. So we talk. However, interestingly, the very last bottom bullet down here, Carpenter versus United States in 2019, the Supreme Court ruled that a warrant is required for phone tracking information. So up until 2019, the US government could just get all the metadata, who talked to who in this country, under the pretext of Homeland Security and national security. There are rules that govern that, but they could do it. However, what happened with Carpenter is that the police, law enforcement, tracked Mr. Carpenter by tracking his movements from his smartphone, GPS tracking. And so it's finally ruled that, at least with GPS tracking, that is personal information, and therefore that cannot be collected legally and used in a court of law unless you have a warrant to do so. So things are changing. This third-party doctrine is changing. All right, so what led up to some of the policy issues that we have today? There's some major acts and laws that were implemented since really World War II that impact what the government does today with your private information. National Security Act of 47. We'll go into this in the next one, but a lot was driven by Watergate, and it wasn't because Watergate was all these laws came into place just because of the Watergate break-in. What Watergate did is it really opened up the spigot to all the other infractions on privacy that have occurred in the last, couple hundred years. So it took Watergate to do it. But there's been infractions and sharing and accessing personal data since we've become a country. So anyway, just a brief overview of what happened. The National Security Act of 47 established the CIA. The important point here is that the CIA is restricted to foreign intelligence and is not a law enforcement agency. Yet the CIA has in the past collected on US people. Okay, so a violation of the National Security Act of 47, which is why we came up with the FISA Act, which we'll get in a minute. The Privacy Act of 1974, this is really important because it really dictates what government agencies can access what data the government holds. So if the NSA wants access to data and the Department of Transportation has it, there are special protocols that have to be followed and warrants in order for that data to be shared between those two different agencies. Now, there's some exceptions with air travel that came in, but for the most part, this still protects government agencies from sharing data with each other personal information data. Electronic Communications Act of '86 really just amended the wiretap laws to include today's electronic communications. Before that, it was a Wild West. And then the FISA Act, which we'll talk about in a minute, and then Executive Order 12333, which really puts the teeth into the FISA Act. So the FISA Act of '78, prior to that, rules were fuzzy as to what the intelligence community, again, our national, whether it's foreign or it's FBI, which is domestic, or DHS, which is domestic, what they could do with U.S. persons' data. And basically, law prevents collecting on U.S. persons if they have no foreign intelligence value. And that means, if it's all local, you can't collect and do anything with it. And if there is intelligence value, you can't just share it with anybody. There has to be a need to know. So that's sort of the high level acts, what the FISA Act in 1978 is about. The details, without a warrant, our intelligence community can collect on foreign intelligence for up to a year without getting a warrant. And that does mean collecting on U.S. persons, which I'll get to in the second bullet. Now, I want to say a few things. That satellite, that image of a satellite, as many of you may know, we have lots of satellites that orbit this Earth, and they collect all kinds of information. They're like vacuum cleaners. They just suck it up. And of course, they overfly the U.S. and they also overfly U.S. persons around the world. So that stuff's collected. But as long as the agency that collects that information takes every step to protect that information, they're allowed to do that. So there's caveats as to what you can and can't collect if you're in the intelligence community. Okay, if you do collect on a U.S. person, specifically you're targeting somebody, they have to have a link to a foreign entity, some kind of a foreign issue or challenge that you're going after, and you do need a warrant. That's required. The bad news is that warrant, it could take, you have basically a grace period. You can start collecting, and then the warrant comes in later. So there's some loopholes in there. And then finally, the FISA Act of '78 established the FISA Court, which is used to review and grant warrants for collecting on U.S. people. So, Executive Order 1233. There's some stuff above there that's relevant to my course I teach, but the big issues down here are the two bottom bullets that it really defined, what is collected, and how to handle that information. The FISA Act was pretty fuzzy about, what is intelligence. So the Executive Order 1233 was there to define, what it is and how you actually implement FISA Act 1978. And then the Patriot Act came, and as I think everybody knows, there's a lot of the pendulum went from privacy to security drastically. And one of the big changes was Section 215, which allowed for bulk collection. It did a lot of things, but for one of them was bulk collection of metadata from the telecom companies. And when I say bulk collection, I mean everything. I mean all the way back 20 years from now. Okay, whatever the telephone company or the internet provider had, all the metadata they had stored, you could grab. And not only that, but periodically the government can come back and collect all that. Keep getting updates to that. And that's what led to the NSA PRISM issue, which we'll cover in a minute. Then later, after it was the Freedom Act, I believe it was, I have to remember here, it made some modifications to the FISA Act of 1978. Again, some stuff above there that's important to the course I teach, but most importantly, data that's stored in a database can now be accessed by domestic law enforcement if the U.S. person of interest, there's a warrant out on that particular individual. So if you're looking for a criminal and you're, say, the LAPD, and you want to access this database of stored data that's been collected by the US government, which is typically a no-no, you can't do that. This section allowed law enforcement to do that as long as you had a law enforcement, or you had a warrant, which, you know, that's pretty scary when you think about it, because you could, you know, warrant can be for anything. And so you could go on a shopping expedition to find out information. So again, the pendulum really moved over to the security side of the house and left the privacy side pretty exposed. You know, good news is it's starting to move in the other direction. And so here's the
Mike,
yeah.
Sorry to interrupt.
Minutes.
This is my 5-minute warning.
All right, we'll move forward. That's not important. This is CF8, 28 CFR Part 23, Domestic Intelligence Processing. So this really impacts law enforcement, domestic, you know, your local law enforcement, the LAPD, for example. So, you know, what do they do with intel? And so the purpose of the regulations is ensure that, you know, criminal intelligence systems operate according to the Omnibus Crime Control and Safe Streets Act of 1968. Basically, it's there to protect individuals' privacy and constitutional rights. As you can imagine, when you're collecting evidence out as a, say, an LAPD officer, you pick up evidence of innocent people, and you pick up evidence even on suspects. But unless they are found guilty, they're considered innocent. Therefore, all the information is collected as part of a you know, surveillance operation, etc., has to be protected with certain guidelines that are provided by this regulation. So that's really good news to know. You can only collect if there's reasonable suspicion that, you know, they're going to conduct criminal activity. But again, you get some innocent people collected in that. So even you know, you got to protect it all. You can't collect based on political, religious, or social views, unlike what happened prior to 1974 and the Watergate break-in. You know, the FBI, for example, which is a federal organization, was spying on local groups, and the same thing with local law enforcement. Well, this guideline prevents that, and you know, again, you have to have a direct. There has to be a real reason to do this, to collect intel in the first place. And then once you collect it, you know, you have to store it, and then you have to determine, you know, who can you disseminate that information to? And again, just like the federal side of the house, there has to be a need to know. Okay, so I mean, this is great that we have, you know, both a federal side and a domestic local side. We have very complementary rules on how to handle and process information that's collected on a particular individual or people. Again, the last bullet, though, is really important. You know, criminal information can be disseminated when necessary to avoid imminent danger to life or property. So there are exceptions, just like every rule, there are always exceptions. And this is one of them. If you're trying to protect someone's, you know, from being killed or something. You have to have an auditing system that tells, you know, that maintains and tracks who has access to the information, who's modified it. You have to label it to indicate the levels of sensitivity. You know, if it's really sensitive or it's just confidential, that all has to be tracked by the law enforcement agency. And then finally, you have to have a process in place that allows destruction of intelligence that no longer is of value. You can't hold that information for more than 5 years. The exception is if it's used in an actual criminal prosecution, then it can be stored for longer, depending on what the courts decide. But information, intelligence not used, can't keep it for more than 5 years. And I bring this up because there is a cross between local, state, and federal data sharing. Okay? And one of the examples of that is the fusion centers that were stood up by the Department of Homeland Security. And we have one right down the road here in Norwalk, thinking about the Navy here. And at the LA Sheriff's Department headquarters, it's called the Joint Regional Intelligence Center, the JRIC, and they take in criminal intelligence information, and they have to handle it based on that 28 CFR Part 23. However, what they do is they make an evaluation along with domestic law enforcement and other first responders as to, is this a local criminal activity or is it a federal activity? If it's federal, then it no longer falls under 28 CFR Part 23. It now falls under FISA Act of 1978 and other supporting and accompanying policies. But if it doesn't fall under that, then it maintains the 28 CFR Part 23. I put this in here just to show you that policies, there's domestic, state level, there's federal, there's outside the federal areas, but there's data sharing between them, but there's gates that exist to protect the sharing between the various different agencies. And anyway, enough on that. So yeah, this just describes what those are. So with that, I think I'm right at the end. Take it away, Yolanda.
That was great, Mike. Thank you very much. Very interesting, particularly the last part of the interactions between the local and the state, federal powers here. Great, thank you very much. So this concludes the three presentations. I think we had a great overview of privacy, security, and policy from Cliff Newman, and then a discussion on how to implement privacy policies, how to do privacy engineering from Tanya Ryutov, and then finally a great discussion on policy and privacy protection in the US by Mike Orosz. Thank you, all of you. We're coming to the part of questions and answers, and I know that this was planned as a longish session for 2 hours, but I want to give anyone an opportunity to pose questions in the QA window. And I'll start us off with some questions, just really interesting things that you all didn't mention that I've heard about, and I wanted to put them in context. So my first question is for Cliff. Very useful to think about not just the confidentiality of the data, but also the integrity of the data. And I know that the OECD had some privacy principles back in 76 or 78. And one of them was that each individual should have a right to correct information about themselves that was incorrect. So I wonder if that kind of provision is integral to security systems and data protection systems. I wonder if that ability to correct one's own data, which implies that I can see what kind of data exists about the individual in a system, right? I can see the data about myself. So is this common practice, or is that not part of the current thinking about data privacy?
Well, actually, it is part of the current thinking about data privacy. In particular, both GDPR and CCPA and CPRA all have provisions, and there are a set of goals. And I focused on really the transparency goal in the limited time that I had to speak. But one of the other goals and the other provisions do provide two things. One, they provide individuals, data subjects, with the ability to actually request that companies provide them with all the information that is protected about them. And it provides them with the ability to correct information that might be incorrect. Now, in some sense, with respect to the data privacy regulations, those are in fact policy issues. So in other words, it is part of the privacy policy discussion that we've spoken about. When we think about security, integrity, well, we saw it in confidentiality and integrity and availability. Integrity is also an important aspect, but it's very different than the policy issue of being able to correct information. When we think about computer security and the issue of integrity, it is simply the ability of the system to make sure that information is not maliciously changed. Maybe maliciously isn't the right word there, but in the sense changed without authorization. Now, the policy issue of privacy policies that give individuals the ability to correct that information is one of the things that would be figured into the specification of policy that determines what that integrity component means. But integrity is also even more important when we think about computer security, because it's not just the integrity of the data that's being processed about individuals or the data of grades or balances or things like that, but systems themselves are composed of software. And the integrity of the software is entirely critical in terms of the security of the system, because a compromise of integrity allows someone to change the system itself in such a way that it would no longer correctly enforce the other policies.
Thank you. That's great. Tanya, I wanted to ask you about the medical data. You talked about genomics in particular. So I read a lot about the tension in the case of medical data of protecting the individual's privacy and the individual data, and the desire of many patients and many individuals to make all of their clinical data available very broadly for more than the uses that they were collected for. So in other words, that they shouldn't be owned by the principal investigator that collected the data, but the data should be owned by the patients themselves and be free to share that data, since it may enable and empower further medical advances, right? So I guess I wonder, since you talked more about engineering mechanisms, I wanted to ask you about technologies and engineering mechanisms where you see individuals empowered or able to own their data and distribute it as they wish.
Oh, excellent question. Yes, that's exactly what's happening. You see, there is the consent that exists right now is either very broad, and even the more strict form of it, such as informed consent, it doesn't really work, because once you sign consent, that's all. Your data is somewhere and you cannot do anything about that. And that's why our work was focusing, that was an issue that our collaborators from there, bioinformaticians from CHLA rose, and we wanted to address it. So we got together and thought, what can we do? What kind of technology do we have? And cryptography is always a great tool if you apply it correctly. So the idea was, well, how can we take consent back once you release it? And the example of technology is what I presented is, if you embed a watermark, which will exist even when your data is decrypted, when you say that after a certain period of time, you can't access this data, but data is decrypted and can be copied. And you share this data maybe with one entity, but the entity transferred this data to other. How can we control this? So if watermark, which you cannot detect if you don't know the secret key, exists there, and of course we need some infrastructure. We're actually building on this. We need infrastructure for monitoring. So we have this audit system, which is based on the ledger technology. It's a distributed one. So periodically you have to be looking at what kind of data is stored somewhere. Is there in watermark? And then you have to look at the watermark and see, well, does this contradict the policy which is embedded in it? If it is, then it's an incident and it has to be investigated, and you can actually go to court with this. It provides you some proof that this was the policy which was protecting this data. Data now is in open, it's decrypted, and the watermark says that that's violation of the policy.
That's very interesting in the way that it empowers the individuals. Thank you. If anybody has questions, please post them in the Q&A window as we're reaching the end of the session. I want to ask one more question about a technology that I've heard of, or an idea that I've heard of, to Mike. So one of the most difficult things in this area is the enforcing consequences. So whenever there's a breach of privacy protections. One of the things that is mostly required is to notify the individuals. However, that's rarely satisfactory, right? Now
Sure.
your records are public, or now this is out. So I think that what I've heard proposals for is the idea of a data trust. So a data trust is a legal entity that binds together the data from many individuals that wouldn't be able to fight for their rights if their data privacy rights are violated. So the idea would be to have a data trust that is common to all the patients of a hospital, for example, or a data trust that is common to all the students in a university, in such a way that the existence of the data trust enables that group of individuals to have some recourse if their personal rights are violated. So I guess I wonder, in the area of enforcing consequences, do you think this is a viable mechanism? Are there other ideas out there to really hold privacy violations, hold people accountable whenever there are violations?
Well, I'm not sure. I don't think it's a viable solution, simply because it's just another data store that could be breached. And I think, you know, it depends on what types of personal information you're talking about protecting. I mean, if you're protecting, you know, addresses and you know, maiden names of your mother or something, that's one set of data. But other types of data, you know, once it gets out there that you know, I'm not going to, you know, some event you went partying, for example, and your photo was taken, and maybe you were in a compromised position, and now it went up on Facebook, and then Facebook allowed a data breach, and then it got out on the internet. You know, if that was in, you know, you wouldn't store that in a data store anywhere. That's just out there, and now all of a sudden, you know, no matter what you do, that's out there. And you know, how do you solve that problem? You know, I think the only way to solve that is to put some teeth into the regulatory framework. And what I mean by that is prosecute. You know, for example, the law that's going to go into effect, the CPRA in January of next year, a year from now, it's going to have an authority to monitor and enforce protections. And so we're going to need more of that. You know, data breaches. A lot of data breaches we have is because of lack of implementing protocols that everybody knows about. We all know about it, but we don't do it because it's too expensive, or it's not that high of a priority on my list, because I'm much more focused on, you know, making money, profits, you know, et cetera, expanding my profit margins, and I'll let that go because it's just a small detail. Well, if you put some teeth into it, that will start to wake people up, wake companies up, wake governments up, et cetera. And so I think really the only way we're ever going to get around this, because technology keeps changing. You know, we're way behind the curve already. I mean, we bring out another malware detector, and tomorrow it's obsolete, right? So we need to enforce laws and make it part of our fabric of society that data is important, and if you don't take it seriously, you will be prosecuted, and you will, you know, hopefully go to jail for it. Not just pay a fine, but go to jail. So that's my opinion. Over.
Thank you. Thank you so much. I want to respect everybody's time and evening, and just we'll close here. I want to thank our three speakers, Clifford Newman, Michael Oros, and Tatiana Ryutov. We are very lucky at USC to have experts like yourselves, not just doing research, but also teaching and helping us learn about these very important topics. Next Tuesday, I hope to see you all at the follow-up webinar on AI ethics and responsibility. It will be at noon on Tuesday, and I look forward to seeing you all there. Thank you.
All right.